Solve by completing the square. Oh, yes, we did this once upon a time, where we wanted x squared plus 8x plus something to be a perfect square, so we could turn it into something squared. All right, we mainly use this to put a parabola in vertex form. That's when we mainly use this. Is 13 the number that works here? Well, if you don't know what works there, we're looking for a number that's half of 8 squared. What's half of 8 squared? So 13 isn't it. So you move 13 to the other side by subtracting it. We wish this was a 16. So we add a 16 here and keep the equation balanced by adding a 16 there. My analogy was the waiter that was balanced and you took too many drinks off the one tray, so it got unbalanced, so you go, right? So you take away, you add 16 to both sides to stay balanced. Now, we have x plus 4 squared is this. It's called a perfect square trinomial. It's x squared plus 2 times 4 times x is 8x plus 16. It's x plus 4 squared. On the right side, you have 3, because that's negative 13 plus 16. Now, if we were just asking for this in vertex form, like what's the vertex, this would be a parabola shifted left 4, down 3. Because the minus, you'd subtract 3 back over to the other side. But if they want you to solve the equation, we can square root both sides. That's going to undo the square. So you get x plus 4 equals, when I square root in the process of solving an equation, you get plus or minus root 3. If that 3 was a 4, this problem would have been nicer. If that 3 was a 9, 16, 25, you'd get better answers. But it's not a perfect square, so it's the square root of 3. To get x by itself, you take away 4 from both sides, right? And typically we write the real number, the rational number before the irrational number. Negative 4 plus or minus root 3a. That concludes problem 30. There ain't no more.